Okay, I'm gonna play a video. Can you see that text?
Yes.
Okay, good. So I drew a picture of the International Space Station. We, excuse me, ended our lecture talking about weightlessness, and I want to show a demonstration of that. Okay, so this is astronaut Scott Kelly. He spent more than 6 months in space.
Scott Kelly imbatan ko delaya karsa tandagin babsi khayenga babsi delaya dawashis theories.
Okay, so on the International Space Station, you feel weightless, and he's gonna show a demonstration of playing with water droplets.
Ko tandage khayenga babsi delaya karsugure. Jimmy Ranjan Sogo Patan, Korang de Tanda to Chugit Patanyam to Timothy Jugan Ambachigure the thing is.
Hi, this is Scott Kelly aboard the International Space Station. I wanted to do a little demonstration of these paddles. They're called hydrophobic paddles, and they repel water, kind of like a raincoat. But up here on the space station, they allow you to play ping pong with a ball of water, and it's pretty cool. Neat stuff.
All right, I just love that video.
I'm going to show you how to make a peanut butter and jelly sandwich from the International Space Station. Every time we eat, it's kind of fun. Everything will float around if you don't manage it. So we have some tape to stick things on our table here, as well as a bunch of Velcro.
I guess the video kept playing. I thought somebody was talking about sandwiches. Makes me hungry for lunch. Okay, so he was here in the International Space Station. And on this International Space Station, you feel weightless. You feel like there's no gravitational force on you at all. But as I told you at the end, there's plenty of gravitational force acting on that ball of water and on that astronaut.
Tanda ngi chetsula kare deshi jeores na tanda ge ani karshe pa khorang tang sendu pa khorang tang ani tanda ge chu ge chu do su de chu tu pas to te gang la ya ani ko te tenshu te pe te khoro mampu ju phogo yo pa te chetsula tenshu yo pa ku gang la tenshu phogo yo pa te chetsula deshi jeores.
And so the gravitational force is not zero. It's not even close to zero. Gravity, you have to go really, really, really far away from the Earth to have zero gravitational force from the Earth. And so the secret is that the International Space Station is moving.
다 텔라야 고 지메츠 누구 준슨지가 레세나 아내가 속에 팀 가영금 밥스 고랑 임바나 콩고 쩌던 거 요레스.
It's moving in a circle.
고 gorlam chilaya 아내 그 쩌던 거 요레스.
And what we say is that the International Space Station and the astronauts are in a constant state of free fall.
저 가리세그레세나 아니 가영금 밥스 당 티나나 요는 그 거치에 받고 쓰임바나 다시 신용 쓰임바나 그때임바나 랑홍기 네바블라 요레스 데시작레스.
So let me demonstrate.
티셰술라야 아니 천튼치고스.
I'm going to share another video.
제술라야 로네 젠다 치탄긴스.
I just need a short one. Sorry, just let's go back. Okay. So you can actually achieve this same effect here on Earth.
다다가 저 스콜라가 가는 바이나 다다게 거기 디지거라 슈첸데 스콜라 가는 바이나 슈첸데 두 스트렌트 요레스.
And so what you have is an airplane.
단데 제출로 여바데 카레스나 데라야 남트 치체.
That does what's called a parabolic flight.
다 남트 데라야 가속에 parabolic 세나 가속 티로다 펜즈게 고랑게 람카 치지 진루고 요레스.
So the airplane goes up and then down in a constant state of free fall.
다코 단다가 남트데 임바네 코야 프로야 프누고 제라야 아니 코 마용거와 parabolic 센다 야홍데 도만도 티시거와 코티 값 임바나 말홍비 값 아니 코 같은 임바나 데 around 홍게 남발라용 거레스.
And so when you're falling under the influence of gravity, then you feel like there's no force on you.
다티 값을 통비 값을 왔다 랑롱게 남딜라 랑홍궁우라 야단다 굴람디네 마용비 값이 바이나 아니 저런 그 가르쳐 그래서나 아니 가르쳐 그랬디 랑홍근이 바틀로 스탄발라야 아니 지메그란스데 쳐그레스.
And the idea is if everything around you, the floor, the ceiling, the walls, if everything's accelerating at the same rate as you, then you feel like you're weightless because there's nothing applying a normal force to you.
다 저런 저런 대사게 컴파 되게 직바탄 시엔다 참하고 뉴는 직바치가 가는 것이었던 거요 바이나 아니 카리오레스나 티 값이 저런라야 슈치가 커요 말이스. 티카치라 바이나 티 값이 아니 가스고다 철로니 저런 강라야 슈기 잔이지요 말와 되그레스.
Let's see what this looks like.
다다게 년디 간다도치 도땡아 수타게스.
Watching astronauts in space has always made us really jealous. Just think of all the weird things that happen in weightlessness and all the demonstrations we could do. Going into space is a little out of our league, but luckily you can recreate a near weightless environment right here on Earth. Reduced gravity aircraft have been used by space agencies since the 1950s. Astronauts for NASA's first space program Mercury trained in such planes, as did all the astronauts that followed. To simulate the sensation of weightlessness, the plane needs to follow a parabolic flight path. It pitches its nose up, and using its thrust and elevator controls starts ascending. By then reducing thrust and lowering the nose, the plane is put into free fall, and weightlessness kicks in. This lasts until the nose gets pulled up again and the entire maneuver can be repeated again. During training, astronauts get around 20 seconds of weightlessness for each parabola in this manner, and often go through 40 to 60 parabolas per flight. No wonder then that a full 1/3 of the passengers become violently ill during this, which has earned these types of plane the nickname the vomit comet.
All right, so this plane is just going up and down and up and down and up and down over and over and over again, and they feel weightless whenever they're falling down in free fall.
단다가 남트티 바이나 코스 대사가 남트티 다 굴람 지르도록 야도 드라마 지금 야도 지금 마용 된다 지금 요레스타 티캅시 바이나 코스 마용 비카스라 말 홍비 값을 다른 홍디랑 신텔할 홍비 값을 아니 코스라야 지세티 차고요 말레스.
And so when something is in orbit, like the International Space Station, it is constantly in a state of free fall. It is constantly falling towards the Earth.
단다게 데이터인 바이나 로와 단다 카잉그 밥츠 데이터인 바이나 코게 다 지메그랑 진짜 차고요 리스커치라 바이나 코 카티인 바이나야 랑홍게 니밥라요 파체 랑홍게 니밥테 인스쿨이 쇼라야 랑홍게 니밥텔라요 레스.
So if you were to slow down the space station, it would spiral into the Earth and crash into the surface.
다 게디 저런 그 가연 그 밥스 되게 적세때 지달라 티시 담바이바나 그 단데가 주고 그다 스쿨라 간라야 아니 가서 그래다 굴람 그거는 코쿠라제치 타마틸레 스쿨라 간라 답크레스.
But the International Space Station is going fast enough that as it falls, it's also moving around the Earth, so it stays in a circular orbit.
그 단담 그다 메트더와 카잉가 밥스도 메트더 그런 거 골람나는 디야데 타고 그쵸 마타와래 뉴스티 지탈라 당바인바이나 타고 스불라가 사거와 인바이나 코타 메트더 족보고네 니텐가는 코쿠라자가 요청 네 사거요 말에 그 메트더 그 골람나데 그요레스.
So if I draw a picture of an astronaut in space, okay, and he's orbiting with the space station, and I ask you, is there gravity on this astronaut? You say absolutely yes.
다 단다데라야 니 거체바치도 스르모트데데 아니 조아 가리트그레세나 거체바 되게 간라야 아니 티오레요 말레스나 가사 고강라야 아니 스쿨라게 텐슈 포요레요 말레스 바이나 아니 체수 렌티 아니 텐시 텐데 포요레세 렌티 자구레스.
It's just that the astronaut's moving fast enough to be in a circular orbit.
That is tambalaya kapsu kurang kashe pakusu imbana kolam laya ne shu chambu shu gon tan jokpu shu ne kurajagures.
So I'm going to draw, and I'm finally going to erase my picture of Earth, and I'm going to draw kind of a few pictures that illustrate this.
That under the chamber chiagi chetu tandaga ane remove this paradis sudete ane kasukulaga paradis sudete pershenda kachitrians.
고도에다
고도
다 단다디 남주 마테치야 디 준데 간조 남주 데조 마툴라 바위나 제도 대가 제기를 했어 단다디 가르소래 지제 매베 촌나디 제기를 했어 근데 제기 나 간조 단다디 로기 겐자 요라 로기 겐자 조고딘데 나로 만도이나 간조 디 단데 제모데 제토그를 했을라다
his question is about the parabolic that experiment that did in the plane. You have mentioned that one, it goes down on the parabolic path. You have mentioned that they feel a weightlessness. So his question is about when we take a flight and usual like airplane, when it comes down, do we feel that? And another part of the question is like if we have an elevator that like accelerating down in a like really fast, can we play that sort of games like in like weightlessness that you usually play in a weightlessness situation?
Yes, you absolutely can. I was going to start talking about that. Let's say we're in an elevator.
저런 지무진의 디그레스 로다 단단가 수기 디콜라야 진대셔가 제시단데 예스 단단가 수기 때때 럭게 요로 럭게스나다 데라양가 수고 럭점 세샤이다 럭점 디 임비원 당사나
And we're standing on a scale.
that thing also 럭점 나나 되어 받지 내가 수 자마치 그가라야 랑데 요레스.
And let's say that this person weighs 800 newtons.
tanga suge meat tege koge ta dusete newton jejain biong tangsana.
And so their mass is about 80 kilograms.
Ta meat tege koge te karsa dusete ka sore sena dusete ani kilogram jechus res.
Now, one thing, let's think about how elevators work. You get in the elevator, you push the button. The elevator then moves up and down at constant velocity.
Tanda nga suge ta lokjam elevator tege leka chetang tela samlutang bai na chu tanda lokjam tina de denu chela ya charangi ani karsugre chine sha bai na loktrwa de ne sha bai na ne ko ya mandu res ya mandu ba de kundu be kapsi bai na loya go sege anyursete tembo kone res.
And so if the velocity is constant, there's no acceleration.
Ta ke ti ko ya mandu ka anyursete tembo bai na ti kapsi nyuno yo ba marwa.
And if there's no acceleration, then there's no total force.
Ta nyuno me bai na te la ya nga suge ya shuki ji chombro ge shugi yo mares.
So the total force is equal to the mass times the acceleration, right?
Tanda nga su shu de ane dusete nyuno ngujurgu garwa.
And it's moving at constant speed, so there's no acceleration. And so you still have the scale pushing on you and gravity. Okay?
Ta tanda de kapsirwa nyurtse tembo kone do bai na chorong ane karsugre. Chorong ta yan da nyegi ti nga suga jama ga lang yo pa ne jama ga yar da karwa ti na jinge ane skola ge thanshi ti ma thangwa.
So if you're in an elevator that's moving very smoothly at constant velocity, you may not even know that you're moving up and down.
Ta ke ti ro chorong ane tanda ge lokcham tinda do chi la yo pa che lokcham tinda do chi ke nang ne ro ane cho ke ti ane ko karsugre ta jokselan jiro me pi gang ni ro jokse tembu chi ka gang ni kun ru ye tinda do yo pa na ane chorong ke ko guchu tang yo me yang chog mares.
However,
Yina yang
if you're accelerating upwards, okay, then you might read something like 1200 newtons.
te ke ti ro ane tanda ge lokcham ti ro lokcham ti yang kure ane nyunon yopi gang ni yan do yo pa na ne chorong ge jama gang la ya jama katsu chingo gre ne chi china chitong nyaja tinda newton chitong nyaja in so tinda ngong gres.
And that's kind of what you feel when the elevator just starts getting going. The elevator is going from zero velocity to some speed, and you feel a little extra force.
Tati kala na nga suga lokcham ting gunzu pickup series lokcham ting gunzu pickup sim baina ko ya chita tampong gunzu stambala ya chor pickup sa ane ko tampo nyokse te leko ne kungu ku yorwa ane pickup te la ya ane chorong la chi shu thepa chi thepchu do ge chwa te le res.
Now you stand on this scale, okay? And let's say that somebody, there's cables that connect the elevator to the pulley system.
Ta da nga suga lokcham me bana lokcham ge gang de la ya nga suga ta thenya ti che ne ko ti karsa thankro yorwa thankro gang la ya lokcham ti ko nga suga ta chakku ge tu thuja sha yorwa.
And let's say somebody cuts those cables.
Ane chamchi la ya ke ti me chi ke ane ko ge chakku chi yorwa chakku ti che bi want ta na.
What acceleration how fast will the elevator accelerate downwards?
Tatus che bai na tanda ge lokcham chi yorwa elevator ti mang khore nyonon ka su gan de chi gres. The toad to the Kuma Saba in Banak, Yonoka Suresa.
Kutsagi. Good Saje.
G.
10. Yeah, 9.8.
Right. So if everything's accelerating down with G, the person is accelerating downward with G. The elevator is accelerating downward with G. The scale is accelerating downward with G.
There is Tananga Suge, Tensular Tumbing, Unity Ganiman Kore, Koma Dugo Restra, and a Unity Ganidugo Resta, Tandagi Nasuga Locham Pila Tigani Dugore, Gigani Dugore, Jamati Bane, Karsa, Gigani Dugore, Unantirwa, and it in Nashi meeting Bane, Unanti Gigani Dugores.
And if everything's accelerating at the same rate, then the scale is not pushing on you and you're not pushing on the scale anymore and it will read 0 newtons.
That's how I teach you back on the Dewey Cup scene by now. And a Karsabura, Chorangaman Krijamagan shooting don't go marry, Jamaga chip on a young question don't go marry, stick up scene by now, Jamaga, Jamatseja, Jamatagan like Choranga Gisete, Nekasut one grace, and then Newton Electro, but one grace.
And so the parabolic flights up and down is just like being in an elevator where you move up and then you let it drop. And then you go up and then you let it drop. And then you go up and you let it drop.
That and then also Namtrig on a good rich or quote and the Gulamla Dutch or Ya Priya Masaki, Ya Palmer Sachi or Tigger is an I saw Tanda Locham Tinder which cannot did it. Yado, Marsaki Batan, Yado Marsaki Bataya, Kuganiton Tsunguris.
Gendo Tiochi.
Yes, another question.
Namgyung on the Namdu runway can take off Cheshagro.
Rere.
Take off Chatang on the Yangsing does it Soras Yongda. And then someone gave me said, what the Dan the gravitational the Devoyers.
The young sons is some good young child Segoroda. Like
The Marge, Namdu the runway can let the Gunegarojina Yashagro. What the Katsam Gala and Yangsing does Sigdo.
Young sons and a Karilla Gorita.
Yang was Sorajiro.
Okay. Okay, his question is about like okay, young moods. Okay. His question is about like when you on a plane and as soon as the plane take off from the ground, you feel like you feel little lightweighted that he said, and his question is that due to the gravity?
No, as you're taking off, basically if you get on an airplane from here to anywhere else in the world, the gravitational force on you is about the same the whole time.
That to Timaris Chorang Karsa Gola Yopain by Nayanroa the Goni Namtuna de Pain by Nayan, Sukula La Tended teacher on La Popi Chitan Shuchurwa, de Halam Chuba degrees.
If I'm the pilot of that airplane, I'm trying to do the best job I can, which means that I would like to take off and gain altitude at a constant velocity. And when I land, I want to decrease my altitude at a constant velocity.
Getting Nara, any Namtriga Kalovachi by na, any garden that Susu say, Ya shoot it on the time, Yara touch you to set the perfect cups in by nine for remission the Kalekalepo, that you tunga on the Praton, Maran Babkas in by nine for Chitunga on the Maran Babelaya, and the Tapshitan Grace.
That will make the people on the airplane the most comfortable. They'll feel no change in their apparent weight.
That they attended the thing could Namtula, the new in Dubaku Sola, Chita Corsorita, Toas and Yamnos and Aku Yashuti, Pichitan Grace, that the Kuruchigo rest, the Karsla, and take up Sukusugi, Jitsela, Shushu, Drama, Tevi, Nitanchio, or the temperature rest.
But if the pilot accelerates upwards really fast, I'll feel a force pushing me into my seat. And if the pilot decides to just nosedive the plane before landing, you'll be in free fall and you'll feel weightless.
That the young Timai Bache Yanko Kaloa Tiger Wako Yar Privika Supetcore Yen Jopo Yanko Prachi or Retinado Chimbana, and it was Charon Chorong Chambuchkumar Tengi Opatsoatan, and it could 야 parnani mamba pickups no stance na ko goti ma tende tama shaja kumar sagi chiga chorwa o tinda do chi che pa imba na ti kap tele chorange ni jime gi so ti chogres.
So when I stand on this ground and I feel like I have weight, that is because the ground is pushing on me.
Ta tanda nga di nga sa thola du slam pickups imba na nga lai kar sugre da chor jitse yo pi chor chi chogo yoris ti kar chi la ba na ani sagi nga ra yang kure ani shu chi jab chi yang kure bijapang yoris.
If the ground were to disappear and I was falling freely towards the center of the earth, I would feel weightless.
Ta ke ti ro thoja ka cha chi la yang nga desa ga sa ti chi me pa do cha chi nga man khur sa ba imba na ni kap te la yang nga range ani jemer gi so ti chogres.
The point I want you to take away is that weightless is equivalent to being in free fall.
Ta tanda de kap se che chu ge samlu na te le ngiwer chi ati kari chi ro chi sena jime se chura jime se te ta rang long se te ni cha ani cha han sun to chong bi ge namba imba te ngiwer chi ro chi is.
Okay, so how does this, I'm gonna draw a picture about how this works when thinking about objects orbiting in space, and then I want to show you a little kind of a simulation demonstration.
Ta tanda nga su ge data te kar su re ta parnang ni ro parnang ni kong yu pu kura ja pick up sun dita ni tang kan yo me te su de she chi ja te ge je la yang nga su ge tan de la yang ko bizu te de zo chi de te ko la ya an che su la du sa tu chi yes.
It's a very hard thing to think about, but you feel weightless because you're in free fall. Gravity is always there. It's still pulling on you, but it's all about your frame of reference, whether your frame is accelerating or not.
Tanda nga su ge jime se ati choya te chi kar su re ta samrata khapura chi yo res imba na de kap se cherang rang hong gu la yo pa ta chang yo res ta tenshu su ko la ge tenshu imba na chorang katu imba na ma ten ba res en tanda ge jime se ati khare la ra le res na ani chorang ge ta tishi su ko ra chorang desa da chorang ge tishi ta ti ge ani gu chola ra le res.
So I'm going to do a couple of examples here of free fall.
Tanda ta rang hong tan re ge pe chung ka chi mu chi yes.
Can we see all of these? Good. Okay, here's the Earth. Here's, let's say, a comet. So let's say this comet just has zero velocity. We just let it go. Where's it going to go? It's going to be attracted to the Earth. So it would move straight down and eventually crash right into the Earth.
Karma to enjiran de dola yo pa che khorang ge nirse ta thoja kajala ya me pando chi chapa imba na ne ku man khurita shaja su ko la ge chola ya ran hong gu la ya sa chi de thamate su ko la gan la ya dus dapres.
But let's say that comet has a little bit of velocity that's pointing around the Earth.
Ta tanda karma to enjiran te la ya ani ko la karsugre nirse tis yo pa che nirse ting aso su ko la ge ta ku ge thala dus te pi won ta na.
And so it's still attracted to the Earth. It's moving to the side, but eventually it will get sucked into the Earth.
Na ko te dus kura japchi dugres duba kanchla ne ko kale tando kura jabi ka sembana sukola skule chola thangi orwa ne thangi thamate la ya ko ne skula gansa dugres.
And then let's say it has a little bit more velocity.
Ta ke te ge nyutsete talontis choyo baina.
So it might spiral around once or twice before crashing into the Earth.
Ta ko sukula gala masa ko ngola ya ko kura dus thamas chigin jad kores.
Now it's in free fall the whole time. You would feel weightless the whole time.
Ta te ka sembana ko kare resena the ranhong nambala yores this tambala jimeg ranjinte chogres.
But if it's moving at just the right velocity at that distance, then you can get a circular orbit.
Ta ketis ro korang la ane skola ge ta skola ne jangse ngi chinchi la ya ane korang la ane jing jokse chigoro jokse tin ngi chinchi yo pain baina ane ko ge ta kolam chigoro kora jaksa ge kolam de ane gorib ge nambala ngres.
And so it's moving fast enough that it's still always in free fall, but it's always keeping the same distance away from the Earth. That's called an orbit.
Ta tanda ti kapsim bana ko kura jagores ko hachan jokpo drogo yetsa kura jagore ya skola ge shogla ya ranghong ge namba yores. Imba na ya ko jokse tin jokpo yetsa ane jokse te la tene deti ane ko ge skola ne jangse chigoro jangse te ko ge jura me pachi ko ge ta nyer deti dus kura jat ki yores.
So when astronauts go into space, they don't just fly their rocket straight up and then stop in space. There's still gravity. Gravity would pull them right back down.
Kanga suge karche patina do ko parna la yan rijichi kapsi imbaina kupete tanda mishu prindana de grwada ko kutsu desatina de ta charja parna ya tangane parna ko tanda ge kolan le sona de atina do maris de kapsi imbaina ane skola ge tenshi tigu ku katim baina ma tentemba de grwas.
When a rocket takes off, it has to get going really fast. It has to get enough velocity to get into orbit. So it looks something like this.
Da dan ti chezanga chu mishu prinda da utina ro chi tanggo yo pa na kola ya de tangbo de la ku hachan jokpo gan ni tanggo yo res jokpo gan ni tang de te ane ko tanda ta korlam ti la ya tatal he tu ba chi chi bu yo res.
So the ships usually take off and then start moving along the surface of the Earth because they got to develop that high speed in order to be going around the Earth and have to be going fast.
Ta tanda nga su ge ti pertitina ro tang bai ba na tambo te la ya ko ta khatka do ro te ge je la ya ane skola ge ko ge ta chungwe la ya ane kar so re ta chi ge nyamru gan se ko ro ta thambe gan ne dus ko ra je ane jokpo gan ne ane ko ra ja bai na ne tanda ge ko ta khorlam se ya chi ro ta khorlam tin ne ko ta tanit ke res.
So the weightlessness is because you're in a constant state of free fall. But in order to get into that state, you have to be moving fast enough to orbit the Earth. Otherwise, you would eventually come down and crash into the Earth.
Ta nga chu ge jimeg ransin chigora jimeg ransin te kati chogre sena ranghong ge ne kabla yo chogyo re swa ta jimeg ki ransin te ranghong ge ne kala chowa kashila ane ko khorlam ga na ne metut debala ya yo chora ta digitia ge jokse te ha chan jokpo chi gu yo re swa ne digitia ge jokse te na ro chi me pai bai na ane ko rimjin te du kura je chi ta yin shok ki mala yo chu ge perti na temba na shinge kale ko mar sag sagene skula ganla ya do sayong gores.
Okay. I mean, this is an important point. The Earth is circling the sun. We are attracted to the sun, right? But you don't necessarily feel that because you are in orbit. You are essentially weightless when it comes to the gravitational attraction between you and the sun. You're constantly in a state of free fall towards the sun.
Ta tanda ta nga su skola imba ina skola te ko tu imba na ko ta nyimala ya kura jago yorwa nyimala kura jago yore ani ko kura jaga te nga ko kollam chik ga ne ta kollam chik na na ta met to kura jago yorwa ena nyimma gi de sela ta bli ki che ba imba na nga su nyimma ga shola ka tu imba na ya ko ranghong ge nebar la yue pares imba na ya nga skola de ko nyimma ga thala kura jastam bala ko ge kura tin jokpo jago yue cha de la tin de te ani ko kar so re ta ko kollam la ya yue cha ani ko ta nyimma ga shola pha la ya chi the tang te ne tang te ta yong go mares.
Okay, are there any questions? I'm going to show a little computer simulation that's kind of fun.
이 좋아요에서 좋아 매번 맨날 단다 때라 내가 속에 lokle jude tanzo juchigora bizu tenado chiga ani ngotochi tangi insti yago yores.
Okay, so these little computer simulations are called FETs. You can access them from any computer, and they're through the University of Colorado.
한다 단다게 딘 바이나 코 lokle gane ko zuya chigora bizu zuya de tanda Colorado University ge tela yores chetu gani baina le de ani karsugre tela tanand ko yores.
All right, so what I'm going to do is hit play. And we'll do a model here. Okay, so here we have the sun, and here we have the Earth, and it's moving at some velocity. And what I can do is hit play and watch it start moving around the sun. It's in a constant state of free fall. Gravity is always pointing towards the sun, and its velocity is always tangent.
Tadana kaso kimala yuchitinga tsugi nima jerwa nima je ani thala chunchunchi yosatinga sukula je sukula tegi nyurseti wi gane kuraja gores ta ko nima thala kuraja gorwa ko la ya tenshu te katim bana ya tv shola te pache tanda de kapsa ani ko karsugure tanda ko sukula ge ti nima ge la kuraja pi kapsa ngasa sukula te nima ge shola katim bana ya ko ran hong gola yores.
I think maybe you saw this demonstration in a previous class, but this is very similar to taking a ball tied to a string and whirling it around your head.
Data chichukishna woman the not today tapa chicken the nova kupa chicken nela ya ni puluchita de takuraja chiorwa what it on.
Now let me ask you a question. What would happen to the Earth if we were suddenly to get rid of gravity? Where would it go?
That day capsing issues like traffic in standard ale de ngola ya your setting also ge karsa tetik in your sayings in the shijaswa. That under get to the characteristics ne keti tandan dig capsroa dig caps ani keti tojaga jala ya tenshuti memberchwa in baina ni skola ko do sares.
Take up her dress.
Take a cola, kangishola.
Koro velocity cut the coin at the dress.
Okay, yeah, in the direction of the velocity.
Yes, exactly. Let's see what happens. I can turn off gravity.
Get gravity map by the towers.
Okay, 1, 2, 3. So it would move in a straight line at that point because nothing's pulling on it.
That take up sim by Nako, tension map chabina, cola, tenio marwa, remare, instambalaya, cogita, tetic and josechi or your sechi or cashotaran and days.
We can go faster. Now, if I change the mass of the sun, what do you think is going to happen?
That Katie is Natsuge and Yamaki did sell and Jiratana Chitu Karichagre Samutus.
Will the force get bigger or smaller? But if I increase the mass of the sun, if I increase it.
텐슈 체르도 고사레스게. 니마 되제 체르다나래 다와.
Yeah. What do you mean by change? You said like increase or decrease?
Increase.
Okay. Yeah, Nimaga disappeared down by Baina and it tenshu Karchiresa.
Jora dore tandati. 텐슈 체르도 그래. 그 야마나 저르 도그래 야마나 파 텐도.
No sato kore no.
야마나 코 나라 사도로 베게 니마 강라파. 야마나 코 저르 도고.
Alright. There are two options. One is that the earth need to go faster, or it will fall towards the sun?
Yes, to be in a stable orbit, it would do both things actually. It would end up have to go faster and get closer to the sun. So let's see what happens. So now we got what's called an elliptical orbit. We can reset. Let's stop.
But
you can see how the force changes with the mass of the sun.
And
the force also changes with the mass of the earth. Let's make them really big. Oh, we hit the sun. So the earth wasn't moving fast enough. So anyway, I just wanted to kind of show you this, this demonstration. I think it's really helpful to be able to play with these things yourself. So please look up these FETs. They are great demonstration materials.
The PHET and Colorado.edu. They got up by not dinner do we go touch Mamboyores and it is Susu Yanko Carsabria. Lolegan is Susu dos cheat fine by not pay all this.
And so, just to give you an idea, this is to scale. This is really what a satellite looks like orbiting the Earth.
That under the temperature is not so good. Corcoran by now, corporate is Colagitala Corajapi, Gita Lamcati, dinner.
Okay, now why is that important? Let's go back to our discussion of weightlessness.
The Karichinication women, the Karichinication is a bina, as with Tampo Kitchen Tabalayanga Sutia, Kangum Karsad. Jimegi
compared to the radius of the Earth, the satellite is more or less near the surface of the Earth. And so, of course, you would expect gravity to be about the same on the satellite as it is on the surface of the planet.
This Tambalaya Chorong get that you can shoot Soraj or what and shoot Sorati, and it's around Sukola Gana de Patan, and it Andagi, Corker Gana de Pani, Tenshu Sorati, Tenshu Chichonti, Halam Doyores.
It's just that the satellite is moving fast enough that it's always in a state of free fall. It never crashes into the planet because it's always moving fast enough to avoid the surface.
Tako take up Simbana, Tande Corcoticati, Mana, Koran Hongo Nambala Paris, Manako, Hachin Jopon Rugo Yuza, and a Cocolam la de to Batan Sukola Ganla Masai teaching yours.
Okay, so that's the main idea. This is an important physics topic that students are always confused about, but weightlessness equals free fall.
Tanda Uncle Income Senator on it, Tatumas on the kitchen, which Chago Bacanchila, Yanko Prisum go Tom Sachi Chagoris. The dick up Simbana Sungi Guatica race, and a Carsa Ramhon Sage or Ramhon Ramhon Titan, and Asuge P. Carsa. Jimmy Swatch or what, but then you chaco a chipine batting you is.
Okay.
The George Tange.
There's a question just.
Yeah.
Gig this is as a Ronlung down the Carsever Jimes in Chibar and Lexsa. And also the Zombili Nimal Kora Jadewara. Ziling Anzola Ronluda and the Jimeniga Yobison, Casidi and Anzo Tsugimida, Hachina Masores. Penanzo di Jagag di Carsa Chagola, Carsa Mission, Korashimbu Jesta, 미드 샤네 사도 디노 데우디 가서 디 초아지 초구다야 가서 디노 진 점블리기 니말 거라자데 가서 초구맹게 소라지 디니 카레나스
chapte kare
자기도 쯤지자 디 칼라 거다 자가 디
메라
사이거스 디니 요라다
ale
뭐 어디나
lore
어디 가시 따라서 가시 지금 양다서 디니 담데스는 부드스디 시시는 거라시 좀 제거다야 어디니 코 초구당아서 고거르지네
te tena kurajan sta ba rama sogre sogma kar sogre lemba
아주 초구도 지 초아래지 초구다 마 가르쳐 버렸다 아 파치 라운드 넘버를 초구들어 디 단당 아주 니말은 점벌리 거라잔데 디 초구면 당아서 단다게 초구매 비선으시다 디 카레나스
yeah. His question is about the earth is rolling around go around the sun, but you have mentioned that earth is always in a free fall towards the sun, but for us we actually cannot feel, and how do you explain that? For instance, like for example, for the kids playing on a merry-go-round, and sometimes if you like go on the wheel and just it circles around, there is a kind of feeling that not exactly free fall, but there's some kind of force that makes you feel something's different.
배는 디페 자나리서게도 가르스는 아주 디 리프트 놀로 만 조금 마 로디 디 런루그 넘버도 소용다야
Yeah.
어디 노지가 좀 좀블리그 데데도 소금도 디 카르레스보다 딜페 자나리서 페시티니
He's also given an example that if we in a elevator that's moving down really fast, and you can feel that small of weightlessness at the moment, the bit of it. So his question is, we are on Earth, why don't we feel the weightlessness due to the sun?
That's a good question. You are on Earth. Let's just talk about planets. You are attracted to the Earth, you're attracted to the sun, you're attracted to the moon, and every other object in the solar system.
Te trope ya dosta tanda nga su chi tan chura tan shuki bana ta chorong da ya nga su ta nyimi gi chimjin na yo pi gi ngipo ta nyimare skolare ta chama gi ngipo chama gi chu gong la ya tan shu chu ko yo res.
Let's say that you left the Earth and you went out into the solar system, far away from the Earth, so that you were in a orbit around the sun all by yourself.
Ta chorong nga su skola ni khatre chi de te chimare thamatla chorong nyimma gi thala ya chorong chipu ta dus kuraja pu gi niwati na chilo he pai na.
Then you would feel weightless.
Ti kap tela chorong gi ani karsa jime granje de chogres.
But but we're close to Earth, and the force of gravity from Earth is much bigger than the force of gravity that you feel, like for example, towards the moon.
Tanda nga su skola gi ngela yo chang chungela yo chang ro ne skola nga chu gong na copy gi ani tenshu ji ro tenshu te ne shenda tong ro ba yin ba na ha chang chenbo yo res picha shana ani dawa gi nga chu gong la copy gi tenshu tong ro ba na skola gi copy gi tenshu te sha chang chwa yo res.
And so the gravitational force you feel is dominated by Earth's gravity.
This tambala chorong gi gang la copy gi te tenshu mang pu yo pe te na ne ta zu chua shi chen don ye te ani skola tenshu te res.
And so what that means is that in order to feel weightless, you have to be in free fall. In whatever gravity field you are in. And if we're in Earth's gravity field, you need to be in free fall in Earth's gravity field.
Chezan ro ta nga chu gi ani ti choya la ro nga chu ge jime ti choya la ya ani nga chu gi te rang hong ga number chi la de go yo res te ke ti cherong su ko la gi tha la ya ani jime cho go yo pa na su ko la gi chola ya rang hong ga number la go yo res te na shin gi ani shenda gi tha la te ro yo pa na shenda ti gi ani than shu kro te na su ko wa ti gi na ne ani ko rang hong go la de go yo res.
And so think about this. Let's say you go to the moon. The moon is orbiting around the Earth. you will feel weightless with respect to the earth. Okay, but you're still attracted to the moon. So you'll feel a little bit of gravity towards the moon. And unless you're orbiting the moon, you'll feel gravity, the effects of gravity.
Da kete chorang asu sukola ni dechi de dawala chi dawige thala kura japana ti kapsu chorang ge sukola ge ta chu sukola ge ranghong nambati chokmare simbaina ya yang tanda ko dawala ya kura jagyo sang yang ko karsu kura dawa ge tembe ge chigala phojugi yang tenshiti chogyo res.
And so it can get pretty complicated. Let me show you something.
Tati tus yang ko nyokta chaudi na chagres tanda tengi yes.
Here is Zoom, back to share screen. So you look out in the night sky and you see the moon changing phases and every 28 days, but this is really what it's doing.
Ta chorong ge te karsa namkhala tabai baina dawa gi chiga pendrum ge namba te ngo te manda manda thongores nimani staje ge nane ta tus manda manda thongorwa ne chiga tongis tabaina chongaten te chongyores.
So the moon is orbiting the earth, but it's also together orbiting the sun.
Te kapsa ane dawa gi sukula la kura jagore ti nansing ge te ta shola ya nimala ya kura jagores.
We would say the moon is in free fall with respect to both objects.
Handa te kapsa bana nga sukar segre sena dawa te ani nima ta sukula nichala te bai baina ya ko rang thong na balan du segres.
Now you'll notice that there are about 12 lobes around this circle, 12 pink lobes.
Handa tanda dus dawa te sukura ga dus kura jabe baina nga su tanda de kura de ga la ya de do karsa. Ta marbu ge daman ro chun ro ta bai baina tin ro dombi chonyo yores.
And that's why the moon's cycle is about 1 month.
Things tambalaya ani nima dawa ge pendru ge ti ani halam ta ka dawa chitang nyungyo chongyo batires.
Okay. So weightlessness is one of those topics that are always difficult to think about, but just remember the important thing is that you need to be in free fall with respect to the gravity of any object to feel weightless.
Ta tanda nga soge chi jime granjin chi wara te nga soge chi ta joshi ke chimu chayo patang ta ti kapsu che suga samlo ta ya te ani kare sogore sena choro ta tenshu ke rawa skora ta tenshu ke rawa kawach kana yo pa ina te ge na la ya ne rang hong gu la yo gu ba chi warwa odingi gu res.
Okay. So are there any last questions on that before we move on?
Ta mumat butu zeta matching la te tan de ge chwa hamachi jayo na any kokatagins. Ayos to ayos.
지워지기 단다 개인기 지난 제야 되다 단다 디 코라 디 카둑 자기 배원데 당기도 남중 먼저 캡블러기 팀 시송 채나 사드 저 코라 조입 제 자거라
네네네.
사 코라 조입 가르치니 자거라 내가 나시 사드 저 코라 카셰 고고 오즈체 단다 까마 더 주르 있는 베디 코라 독스 동동도 그래도 저도 디 간데 체니 용거래 다 당기 제모데 제와 나시 채나 다다 되면도
네네네. His question is about the orbit. You have like on the simulation with the orbit is really exactly circular, and with Kepler's law we don't have a really like a circular orbit. It's oval shape or like
Yeah.
right. So his question is why the orbit is not not circular, is elliptical.
Yeah. So for example, here's the sun. Here's the earth. And I'm going to draw this kind of accentuated. Okay. And I think this distance is something like 93 million miles, or I don't know what it is in kilometers off the top of my head. So we'll do miles, that's okay. And this distance here, when the Earth is over here, is something like 89 million.
다 단단가 수 니마티 기티 스콜라게 콜람티 아니 코 두시바나 다 초치라 예쇼타텔라야 코게 마일 사야 고슴도와 연쇼타텔라야 마일 사야 제차구요레스.
Okay, it doesn't matter the unit. The point is that the Earth actually has an oval or elliptical shaped orbit, and it's a little bit longer on this side than on this side. So it's not a perfect circle.
다고 고고 따따요 말에 단다게 지시되다 슈이 챕터요 말씀바 단다 벤티카리 인사바나 고기 골람티티스 용비요 바강실라 네 이쇼타티티스 영화도 연쇼타티티스 통하요레스.
And the truth is that the circular orbit, although we draw pictures of circular orbits, is actually a very, very special case.
단다 참 가수가 지금 템비 값을 골람티나 because column team bana nga sugi ta ji gorib tak tak chigyo re simbana gorib te ne ko ta khar sugre ani tang amxewa gi kapsi chi chongres.
And in fact, every object, every planet, every comet, every asteroid in our solar system that's within Earth's, sun's gravity is following an elliptical orbit.
다 속에 님에게 침진하나요 비기 다 자레 니 카마토한 지랑레 뜨가 다와레 티 참마 아니 참마게 고게 드사게 롤람치요와 고수게 콜람치요와 테카레스는 용여브레스.
You can actually show mathematically what the shape of these ellipses are, depending on how fast the planet's moving, and how far away it is from the sun.
다 단다게 고 체랑게 다 단다게 다 님이 침진하나요 비게 자카르탄 카마토한 지랑 라소바데 토임바이나 초랑게 쿠게 족세 같이 두고도 아니 님마타 타랑로레샤 가소레샤세 때니체 페치톤 데테 안가소가 안스글람니 아니 코랑게 드로사게 주사게 줄람치요와 딘 종이 마테 튼크레스.
But most planets have an orbit that's not a bad approximation to a circle.
다 만치신 바이나 코게 다 지가 할람 다 코게 콜람 테 할람 고립 당 테스트 컨요요레스.
But yeah, good question. They're mostly elliptical. Like, for example, I can bring that back up.
Yeah, his question is, what's the reason behind this elliptical, not circular?
Well, I would turn that question on its head and say, why should it be circular? Circle is very, very special. Why should something be special instead of more general?
다 집단기 매너가 쪽에 조아테 란자 타란탄게 있으와 아니 지양고 아니 양고 고립 딱다 인구는 진생까지스 인구 개파나 인구는 진생까지스 다다 고립 매너고 걸럼 그나네 다 지금 종류 그나네 지양 제적 방식이 지차기です.
So
Can I ask one question?
Yeah.
Actually, I have a doubt. I just want to clear. Can we say that the reason for satellite not colliding each other is because they move at different velocity in order to stay at their respective orbital?
Could you repeat the beginning of the question real quick? Why did the satellites don't crash into each other?
Yeah, can we say the reason for satellite not colliding each other is because they move at different velocity in order to stay at their respective orbital?
That's right. That's right. I mean, if they were moving at different velocities, they would have different altitudes as they orbit. If they are orbiting at the same radius, then potentially they could crash into each other, but they would have to hit each other just at the right time. right? Because remember, they're doing this in 3 dimensions. So they're orbiting, you know, like this, and they would have to hit each other just at the right time. So you can have collisions in space, but it's rare.
Okay, then I will translate that into Tibetan. Then the Gela draw theatrical is and then so corporate in the Panone Donka Jacomano Jinsenti Kusuga, Yana Akarsure, Joseti Mando by Metanir, stage race, Jose Mando, Tene, Yobi Duck race, then Jose Mando Estambala, Kugis Sakula Muni to say Mandola Yobu, in Stambalaya, Ne Donkajaya, Chetang in Bana, corporate in the Pan Donkajaya, Discoveries. Tim saying Shenda by now Kuga Karsure. Kugitan Jose Chipa Yopa by Nang Asuki and Nitan the decision Stambalaya, Chucha Sundengi Mula Desija pick up same by now, Chucha Sundengu Mula Summit of the Desija Gorwa, and by na take up same by now, Jose Chipa Yopa and Corlango Cortamando, the Rua, or Tilatin de Dete, Yanko, Donkam Nitan Goris. Yes.
Okay, well, I'm going to talk about the different kinds of orbits real quick, and then I want to move on because we don't have that much time left.
That column Rigmado Kati, but the Sichet, the tricky is that social hamindus.
Okay, so here's the sun. As you know, you can have circular orbits, but the velocity has to be just right.
That and I chair like any Karsabure. Gorlam the Gormu Yonat Queries, Invana the Yobichalaya, Cholaya, Nurseti Petapa, Tapa to go yours.
If the velocity is a little bit different, you could have elliptical orbits.
And that is considered like a secret. That the Tame by Banner, you said the Tame by Banner, Chorango Corlam, and John Ibugamola Chavores.
And in fact, most comets, like Halley's Comet or other comets, have these really elongated orbits where they go very, 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 very far away from the sun, and then they come in really, really, really close to the sun.
That in Shingi and the Natsu Kermato and Jiranga Kashura, doing by Bana, Kuge, Kugu Kolam Chura, Titado Yores, right? Gilaya pet in Yamalet Salatore, and take Chela Kuyanchukuro Cornstambala, and you might not knew the name Grace.
And in fact, some objects can come into our solar system, but they're moving so fast that they can't be captured by the sun. They just circle around the sun and then they leave the solar system.
To Pananging Ubakashi by now for Petis Hachan Jokwarwa, Nimagi, that Nasumi Chimjishala Yonko, Kuachan Jopondo Yetsan, Nimagi, Tenshu, Tent Kiyomaro, and Yimichola, meant to Kutus Korajeche, Yonko, Yimichimjini Cartage to Snugaris.
So when the solar system was forming, okay, there's lots of different objects in our solar system. Some of them are, and their velocities are rarely exactly right to give us a circle. We get lots of elliptical orbits, and some are close to circular, but nothing's ever a perfect circle.
That take up some as Nimichin on your picking with some other those Kurajachi to go, right? Take up any the Mount Chishi Karisena. Any cool column tin Jong or is Kashichi, any Kasuri that you remove a yip down Tanyo is.
Okay, so nature doesn't always give us, even though people have been drawing these orbits as circular, which is like how we learned them originally, it's easier to understand, they're really ellipses.
Matsugo something Jaya Tantina Kasumi, Bana could Deshaja, the Tabio, Chepechiku, Column Tikanza, Boru move on the Deshaja, that somebody go in by Naya. Don't miss the Ranshon Company, Column Tikanza, any page you at the square. That's how much the team will you rest and the John will you rest.
Okay, so there is one other topic that I'd like to discuss, and then maybe we can just kind of end with some questions.
That Andangi Dela, ni jo shi chi ko la ya motor chi ni to sons ne te che no che la ya ne nga so ne lam sin ji de bi kap so nga so ge ne to ta leng mo ne ji de na de dus.
Okay, so has anybody ever lived next to the ocean? How many of you have lived next to the ocean? Raise your hand.
Ne jan so ta tha nyu la ya ne chi de nyong ju tin da yo ye sa.
Just a couple.
I see chat and I think
Okay, so for anybody who's lived next to the ocean, you are very aware that the ocean has tides.
Ane kete chera ane jansu ge thani chi de nyong yin bai bai na ro ane che su ge jansu la ya nga su ge tulip la sto ba tulip sa the tide sa sto ba te yo ba de che su ge single chres.
So this would be low tide.
That de tanda ge ne kapri kar res na ko tulip te ma wi ge kabla res.
And then this would be high tide.
That tulip thui kaps res.
Why do we have tides?
That tanda nga su ge tulip sa chura tu tong tulip tene de tan chu ge kar su re da. Lab the mando yung go ro ti yong nu go johnson kar res.
Anybody?
David
There's an object that is responsible for tides.
Yeah, someone said because of the moon's gravity.
Exactly, because of the moon's gravity.
Taran jares ro nga so ge tulap ti ane dawa ge tenshila tren gores.
The moon causes the tide. So let's just say the moon is here, and let's say the moon doesn't move very much, and the earth rotates in one day.
Da ke te nga so ge dawa te ko shu shu la ya kars go chu chambu chi tang me pa che ane nga so skola te nima chikna te le kurashi jagwa.
How many tides should we expect in one day?
Te bai na ro ta nim ka skola te nima chikna te le kurashi jagba te la she bai bana ta skola gi gangi nima chikna la ya nga so la ya tulap te thama ka so chong sa des.
Well, for anybody who's lived next to the ocean, they know we have 2 high tides and 2 low tides.
Ta jansu thala deni bai na kare ha ko res na nga so la ya tulap thu ani ta ma wa ni yo pa ha ko res.
So let me draw you a picture of how you think this might work.
Ninga chetsula tanda de Canada chi yemen te ko la ya ane remote trees.
gonda chimbo shibali gu dus jansa lop shoge chunju.
He said that the tide is high at night and low in the morning or the day.
Well, you actually get 2 tides in a day. So the
통한 이용 그랬어.
let me look at the Okay, so this is going to be the wrong picture. I'm just going to tell you up front.
That and that remote not the yours. The tamponen is.
I'm going to draw a picture of what the ocean surface looks like around the earth.
That the cause ane sukolage talarwa ane kasa shuti Canada chi mete trigens.
So you might think that the earth, that the moon is pulling on the earth, and that the ocean would bulge in the direction of the moon.
That's so some grace, some subgrace, 아니 다와기 니마 다와기 스콜라티 파 땡기요 정티게 텐슐라 때니 다와기 텐슐라 때니 베티 아니 스콜라기 탈라요 비 추디 아니 가스그레 다와기 쇼라야 팜 범버치고요 바치라 삼 스그레스.
You'd say, here's the moon, it's gonna pull the water towards this side of the earth.
이 담발라 틸라테네 데티 로아타 다왈라테네 데티 스콜라기 탈라요 비기 추디로와 아니 다와기 쇼라 템바치라 삼 스그레스.
And that if the earth spins once per day, then you should see one high tide per day.
아니 딜라도 지 삼리로와 딜라테네데 스콜라티 니마치라야 코랑코스 치자고요와 디스탐발라 랑코스 치자고요 파이나 나술라야 다발라 템비게 티오로와 딜랍치오로와 딜랍티 아니 토마치라 요안도로와.
But that's not what reality is. The reality is you see 2 high tides and 2 low tides per day.
동유스티 마레스 동유스가 속에 딜라투아니 타마와니 통고요레스 니마치그레나.
And so really what the ocean's surface looks like is this.
다동유스가 속에 스콜라게 탈라요 비기 지추요와 추기 뉘딘데라로요레스.
So the force of gravity, when applied to Earth, makes it stretch out like an egg.
텐슈티 스콜라 포비캅스 코게 가스그레 다텔라테네데티 니코베 타기 추데 아니 가스 당아서가 공화가 예부게나신 파 담기지그레스.
So as the Earth spins, okay, as the Earth spins, this bulge passes over wherever you're living, and then this bulge, and then it resets. So you get 2 sets of high tides.
다텔라테네데 스콜라 코라자 피캅스 아니 가스오게 지가스그레다 다 토마냐 용거로 저저 이쇼사 당연쇼사 때 투아도 텔라텐데 파슬레 시킨테 고라 텔라텐데 땡아 줄라야 아니 가스그레 딜럽 투아니 타마니 용거레스.
And so then you might be wondering, but how is that possible? I mean, shouldn't all the water be pulled to this side if the Earth's pulling with gravity?
That is the Bangasu Samona Kari Tengresena. 알레디 카사 다와키티 파조사 파탱기오 바네 추 정말 쇼치를 누구 말이오 있다 삼식데스.
And okay, so here's the secret. The water is in free fall with respect to the moon's gravity.
다 티캅스 포타 동위기다 상와마소나 카레레세나 다 dawa tang turji ke je pa imban dawa la tene ke je pa imban sukula ga yo pigi chuti ani rangthong ne balwa yo res.
Normally the ocean wouldn't care about the moon. If it's in free fall, then it would feel weightless essentially with respect to the moon's gravity.
This tabala ya sag kola ge chungla yo pigi chutege 아니 그 나와요 메라 프로 찬적 프로 지금 말이스 아니 게티 코라 다디캅스 코 라운홍 네발라 예타나 아니 그 가서 그래다 거기 나와라 텐데티 아니 지메그랑지 저기요레스.
But here's the secret. The earth is big enough that the moon's gravitational pull is different on the back side of the earth than the front side of the earth.
that is tambala dikaresena asuge sukulage tasukula hachan chambuyo chang sukula gangla ya ani dawagi tepchugi tioro kasa tepchugi tenshuchi orwa te ani sukulage chonin chabala ya mandayo res.
So there's a difference. This arrow is longer than this arrow. There is a difference in the gravitational pull from one side to the other side.
That ngasugan dato tabay bana yesuk dato de ringwa tong yesukti thongado wa de kapse sukolage tati phajot se shon inshallah ya tepige ani tenshuchi orwa ate mandayo res.
And so whenever you have a changing gravitational field where one part of an object feels a different gravitational field than another part of the object, then you can get stretching and compressing forces.
딱 유부 지기 초니라야 아니 슈만도 아니 테피 값이 바이나 티나도 그네 탄텔라 아니 고 네탄디게 값을 가르치 그래서나 유부티 지기다 유부티라야 너총 그런신데 아니 너총 너와타 야나 고 츠라지오라 너총게 지게나 너와타 츠라게 슈친테 레기오레스.
So this side is pulled stronger, this side is pulled less strongly, and because of that, you end up with an overall stretch that pulls the ocean in this direction.
다 고에 쇼살라의 수치와 대바당연 쇼살라의 수치와 되게 전단다 되게 값을 아니 고다 차창 냠타 다바인바이나 아니 고 두스타치 가서 그래. 공입게 이블라야 파텐주가 소들이게 그래서.
So let's think about this too. Let's say you are a person in free fall.
다 데라야 양칭아서 사람들 현대지 강상을 담바이나 게티 체랑으로 아니 랑홍그 무라요 비기 네탄테나도 질 차샤바이나.
And here is the earth.
뭐들라야 스콜라지.
Now, your toes are pulled down with some acceleration g.
대처럼 그 감바티 많고리 년은 G 경우가 생겨요레스.
We'll say G1.
다 G1 G 비차샤기스.
And the top of your head is pulled down with an acceleration G2.
대처럼 그 고기 차시지오로 때라야니 년은 G2기 템바이나.
Now, normally we say this is all just G. It's all just 9.8 meters per second squared, and you're in free fall.
남진 바나가 수가스 그래서나 G 세대 G디 시바레스 G디 굿사 제레스 굿사 제 바간슬라니 체랑 랑홍가 남바요레스 데시자그레스.
But the truth is that G1 is a little bit bigger than G2 because your feet are a little bit closer to the earth than your head.
동의스 셰바인바이나 디 값이 G1 디 G2 리티스 쳐요레스 카실라바이나 저런 그 감바데 아니 고리 사단 타티스 뉴어요와스.
So G1 is greater than G2.
디 값인바이나 G1 디 G2 리 쳐요레스.
Now, this is a very, very small effect. When I jump out of an airplane or I'm an astronaut in space, yes, there's this stretching force on me. This side's pulling harder than this side. It wants to stretch, but I can't feel it. It's so small.
임바이나야 디 값이 하청 총총여서로가 지금 남전원의 총반도 당하야나 단다게 반원의 같은 데바트는 도임바이나 디 값이 고 태야 탱그레스 와다 고 랑홍근 네발로 픽업스 태야 탱그레스 다고 이 만도요 전 지대와 임바이나는 하청 총총인 전 되게 숙제인데 저거 말했어.
And in general, this is a small effect. But here,
주동임바인 되게 숙제인데 하청 총총레스.
and it's true, even the tides are small. They raise the ocean up and down by meters, whereas the radius of the earth is thousands of kilometers.
단단데 값임바나 대시바레스 비차샤나가 속에 추게 딜럽라 타바임바나야 딜럽퍼 단 차브값스 다 미트치스야 판도 호레스 다 티게 파이가 프레차데 스콜라기 미트치스 파바나 스콜라기가 속에다 거기다 지철라 타바이나 페테 킬로미터 tontom으로 왔어.
And so I always like to think about that. You know, it's a small effect, the tides. It's not like they go up and down by that much.
단단데 값이 현지토한테 가래 인세나 지금 딜럽티 중고요르데나 딜럽티 아니고 벌써 슈첨부 슈지 매바고 슈첸데 하전 총총레스.
But you have to remember that we live in a very special area. We live on the surface of the earth.
이나양 가ring이 부그레스나 아주 살짝 대사 묵세지라 요레스 아주 스콜라기 중요라 되기 요레스.
It's very small. If we go a few kilometers in the air, we can't breathe anymore and we die. If we go a few kilometers into the ground, the pressure is too high and we die.
Tati mukse sacha mukse chigase jumsente karsene kete nga su sukula ge chungwe ne ro kilometer khashi chiya parna ya simbaina nga su utang maro cheshe no gres kete nga su sukula ge nalo la man khore ya this to by baina yang ko ge chiga nonshila tende de nga su mares.
So we notice these small changes.
Chitang nga su ge tanda ge ko ge jirwa ta chong chiyo pa ti yang churgu res.
But the important thing is that the difference in the gravitational pull from the moon causes the ocean to stretch into an egg.
Tati tanda dika singi wade kares na ane dawa gi tenshila tene de ane ngasu gi ta jansu chigoro jansu te chi ha tsu tende de ane ko gonga gi la pa zugi pa tingi gu res.
And so I wanted to mention that just because, tides are something that's so, easy to see, but to understand why there's two of them in a day, you have to think a little bit about gravity.
Tanda de kapsa desha jaga tsu de karin sena ngasu gi ta namji thoya gi chi dilab imbaina namji thonde gi res imbaina nimachina dilab de thongma ni sgora da cha de na ni yongunu jinsen ka res istambala tin desha jaga la ya ani tenshu ke ne tante chang de sa ku res.
Okay, so we have about 8 minutes left, and let's just have questions.
Tanda ngasu karma this lashas karma je sam lashas ne ngasu draw the lens yes.
I know everybody's very tired.
That's sama kale khayo pa haku.
Hello, dinga chwa chiye.
So inchina so
Allah so. And my question is that is there a specific Hello?
Good.
Is there a specific time in a day where where we can say that okay, we have two low tides at this particular time and we have two high tides at this particular time in a day?
Yeah, that's a great question. Generally, there's two low tides and two high tides, but the exact times that they happen shift a little bit. That's because the rotation of the Earth doesn't necessarily care about the movement of the moon. So the Earth rotates in one day, but the moon also moves a little bit in that one day, right? Because the moon takes 28 days to do its orbit. And so these times move and drift a little bit.
Tanda tuate ka lana ngasu ge tulap chongwe kapsa tule thua chongwa tang tule ma chongwa te ngasu yang titsu ngichin chila chongwa te da yorwes wa ati ngichin yomares ko samson titsu te chongwa gi thul karsa tule thua tang ma chongwi tule tisin jonjo tegres karsila baina chilgi ta ngasu skola te rong ko jabe kapsin baina da ko ti chigro da Chunistachina Kurjago Yores, Imbaina Yanga, so Tig Caps, Dawati Scola La Kurajago or Warwa, Dawa Nimanistajina Kurajago, some Kogeta, Nisati Latis, Joyo Palatendete, Yanko, Tilap Chonye, Tisute Yang, Titis Mando Yores.
Yeah, so it has to do with that the moon moves a little bit when the Earth spins. You have to take that into account.
Tata de kapsu ko titsu ngiten me pas ko ra ta te ham ko de gala na skola ran ko je bi kapse yang dawa yang ko skola ke thala jen ko ko ja ko tis tama ko ne satelite sinjoran du yo ran joran du yo pa ke ne tan nga su ke kapse yang ko tigna la ya kapse ta nyam chi tigna le tsha de tam ko chogo chi chag yo res dawa ye guchu tig yang de la chen chi yo res.
I will say though, it is all predictable. You can look up the tide schedule weeks in advance.
That day, and so young court support it in the race, and so get that you love John get to say, and you don't sugar money and support it that deposit in the race.
And that somehow speaks to our power in physics to be able to calculate things, that we can use Newton's law of gravitation to predict all of these things.
대가라 나가 속에 인컴 센터가 다 언스당 인컴 센터를 되는데 하버트 단다 뉴트론기 텐슈크 텐션라 소파 비치당데 단다게 답답스 그요레스.
And so I think that's what I love about physics. It's nature's way of communicating with us. It's telling us what it's going to do. We just have to understand its mathematical, language.
다 대가 인컴 센터가 간누고 전세대한테 인스로다 인컴 센터 가서 런션 감고 가서라 연대에 여러 캔데 여러 스페셜 거다 이반 띵가 수기다 직시야 도야 되라야 내가 수 인컴 센터가 텐텐당다 하버트 단다 언스기 타면 제대 다 고고라야 당 지금 파 첨부지 듣고 그랬어.
Hello.
디럽징도 나군이가 바르조가 된상도 이마지가 담만이 노냐 다단단디 드네 좋아서노 거린즈 군디 정업 쳐가지고 시콜란 정업 쳐야 돼 거기 다단다 디럽 그 강거라서 너 꼬라 잡디 강라 쇼 담절로 꼬라 잡되어라 또 담절 꼬라 잡도나 디 잠바도나 잠소요라 하나 디 조사돼
그 타겟에 잔수리다 이야
다 참아 잠소요더라 다타니 디 당가서 공화가 입쳐야 돼. 쇼지여라 나르조만 저대어라 다가리나면.
네네.
냐마도 같은데네. 때 잠바도 마테가 고르고 코르주지 바로고. 다 쇼니 마코라지. 다 너희나 카르탄 디 샹탄 로니가 시우 코르지. 야라 텐지. 너브라 카르니가 되면도. 난군이가 쇼지가 된 정도도 가리나.
His question is about on the moon or on the earth because of the gravitation from the moon. You have two arrows that's showing on the same side, same direction. What is that? Because like if you think about moon orbiting around the earth, it just go around the earth, not on just one side. So his question is about the two arrows directed in the same direction.
Yeah. I just drew what these arrows represent the total gravitational force on a little piece of water on both sides would be. So this is FG and FG. And the arrows mean that the gravitational force on this side is a little bit bigger than the gravitational force on this side. But it's both of these gravitational forces are due to the moon, so they point towards the moon.
단다게 되게 다고 다다된 자게 대한테깔라 나스 스콜라기 다 중기라 옆이 추기다 니들이레레레 강라서 그러다 진진된다 강라야 포피기 텐슈티 땡기요레 심반다 단다 되게 다 스콜라 그런 게다 최종대 하전 전부 요정 네 쇼사기 라요피기 추가 태피기 다올라테네 태피기 텐슈티 아니 연쇼살레 연쇼살라 요피기 추가라 태피기 텐슈리 디스 쳐요 바데 디스 쳐요 바 슈처버도 마 디스 쳐요 바데 데템바이엔스.
Let me draw another example real quick that'll help you think about this. Let's say we have two cars. I need more space. Hold on. I'm going to erase the wrong picture. Okay, so let's say we have two cars. And let's say we tie a rope between these cars. Now, if both of these cars are moving at the same speed, what will happen? Will the rope stretch? Will the rope sag? Or will the rope stay the same? They'll stay the same. They're just moving together.
런자 대거 와 가시라 반에 이체냠도 두고요. 와.
Okay, now that's true even if the cars are accelerating, even if they're speeding up.
나신 계란이셔 그 뉴스 직박간에 두고요. 바다 연어양 직박인 바이나야 진주가 두고요. 바이나야 티 다란제 되겠어.
As long as they're speeding up at the same rate, that rope will stay the same length.
다단다 되게 타바되게랑 센티미터 때가 되게래서 가티스나 코란이체 다치가 뉴스는 주란 두고요. 바이나 뉴스는 주란 두세 직박이나 란제 되겠어.
But what happens if one of them starts accelerating faster?
다 신다디로 강롱지 아니 지게 뉴스엔 조라테게 뉴는 데베디 진조가 침바이바나 뉴는 대야디 7 침바이나 가르쳐 그랬다.
You'll start to stretch the rope.
당가서 타파데 파 정그레스.
It's the same idea. If the ocean's being pulled a little bit more strongly on one side than the other, you're going to stretch it.
다데 나신데스 다나가 데탄 총이 간에 데캅서 코 진조가 지치대요 바이바나 뉴스에 조르 뉴는 조르 탄테로 뉴스 조르 던 뉴는도 만도 바나가서 타파데 탱그로다. 정식 지레그로다 나라. 데 나신게 아니 스콜라기 기 추가라야코 다 텐슈 포코레 나 쇼치라 파기 텐슈데 셴달리 아니 티스 지 총아요 바이나 아니 쿠강라야 아니 나수 가르사다 너그레스 this time 고레스 너령 고레스 나너차그레스.
Yeah, it's the exact same idea. You can think about if they're accelerating together, they're in free fall together, but if they're accelerating at different rates, then you get that stretch.
다티가스라 데니차 다 고고렌탄 치파레스 케티 코란니차 아니 가스그레다 뉴넌치알라 체시파이나다 정마로와 뉴넌치 요바칸실라 뉴넌 세티만도 엠바네 토바창와나 신 단데디갑시 바네 쿠티스 남르차 당창야 되는고요레스.
Okay. If we have time for one more question, that's fine. Otherwise, I will try to, if you have other questions, you can put them in Google Classroom. And I'll try to log into Google Classroom and answer those questions, in the coming days.
아니 단다 치소요나 좋아치스로네 단다가 치소민도가 되게 게디체스라 좋아요 바인바네 좋아된가 구글 클래스룸 나라 두스 치소 지샤나 되게레스 아니게 근데 다 선연하는 지 갈레치스 좋아도줄 렌자기인스. That's great. Thank you.
All right, now you know where the tides come from.
This is that and that is the love said the Karchinetani Chomba de Hakures.
Okay, thanks everybody. Good night.
Boy, 2 cheers and Janango.